This is chapter 5-7. This is our first factoring where we have to do some more complex things. Up until this point, we have situations where we look for, first of all, we should always be putting our expressions, and we are factoring expressions. So factoring expressions. And first thing we should always do is put it in standard form. Standard form, make sure it's in descending order. Number two, we're going to look for a common factor. Common factor, that's always going to be our first step. And why do we factor? Why are we factoring expressions? We're going to turn addition and subtraction, 2 terms, 3 terms, 4 terms, 4-term expressions. We're going to turn those into products. That's what factoring means. So the first one on how we can do that is by looking for a common factor. If there is no common factor, then we're going to look and see, is it a special case? That's not how you spell case. A special case. And in 5.5 and 5.6, we went over those 2 special cases. Difference of squares. I should just write that out, sorry. Difference of squares and binomial squares. Those were the 2 special cases, and we should binomial squares. So difference of squares has 2 terms, always has 2 terms, always going to be subtraction between those 2 terms, and both terms are going to be perfect squares. Hence the definitions of difference, subtraction of 2 squares. If they are the difference of squares, then we can factor them mentally. We know the technique of how to find out what those conjugates are. Binomial squares have 4 things. Binomial squares are always going to be 3 terms. The third term is always positive. Our first and third terms are going to be perfect squares. And this is the hard one, and there's 2 different ways of going about doing this, is our middle term is going to equal 2 times the square root of the first term times the square root of the last term. And so those are the ones that we will do mentally. All those. Common factor, we're going to factor out a common term. Special cases, difference of squares, binomial squares, we're going to do that mentally. And then number 4, if that doesn't work, if it's not any of these, then we're going to do A times C, and that's what we're going to work on today. A times C, we know that all of these trinomials are written ax squared plus bx plus c, where our A value is going to be the coefficient of x squared, and our c value is going to be the constant. So we're going to learn a technique today. We should get to the point when our coefficient, when our A is 1, we should be able to look at this and be able to do it. But I'm going to teach you A times C. We're going to go through all those things. Is it in standard form? Yes. Is there a common factor amongst the 3 terms? No. Is it a special case? It's not a difference of squares because it's 3 terms. It's not a binomial square because the third term is not a perfect square. So we're going to do A times C. So A is 1, C is 3, and now we find factors of 3, 1 and 3. When the signs are, what do we know about the signs? Remember, this is a product. this is last times last. Remember, this is outside plus inside, and this is first times first. So we know that the only way you can get a positive third term is if the signs of our binomials, down here, of our binomials, are going to be the same. It's the only way you can get a product. What two numbers multiply, this makes our last term, multiplying those would give us a positive. Well, they could either be both positive or both negative. Now, if they were both negative, remember, our outside and inside would be a bigger negative. If they're both positive, our outside and inside will make a bigger positive. So we look here and we see, since our signs are the same, we know that they are both positive. So when I look at my factor pairs here, 1 and 3, I know the signs have to be the same because this is a product, and I know that they're both going to be positive. So that's a nice little trick. And now, if I add 1 plus 3, it equals 4. And there is my sum. Remember, this is a sum, this is a product. So a product of 3 and a sum of 4. So I'm going to break this down to this form. How did I get this? Well, all I did was I took this x squared and I pulled it down. That's all I did. I brought that first term down. The third term, all I did was bring it down. That just was brought down here. And then my middle term, I broke it into the sum of two things. Remember, this middle is a sum of the outside and inside. And I was able to produce that outside and inside by these two numbers. So 1 and 3, there's a 1 here and a 3 here. So all I did, because x plus 3x still gives me 4x. So I didn't change the value, I just changed the look. And I turned it from 3 terms to 4 terms. The reason why we do 4 terms is we are going to do what we call factor by grouping. Factor by grouping. And I grouped the first 2 and the last 2. And I'm going to look at that first 2 and I'm going to say, hey, is there a common factor between x squared and x? Yes. I'm going to factor out an x. If I factor out an x, I get x plus 1. X times x is x squared. X times 1 is x. So all I did again was change the look. I'm just changing because I have to turn this from addition and subtraction to a product. So I have one product right there. I'm going to look at the second grouping, 3x and 3, and I'm going to look, what's the common factor? Is a 3. If I factor out a 3, I'm left with x plus 1. Notice 3 times x is 3x, 3 times 1 is 3. So I again didn't change anything, I just changed the look. I was able to factor. Now, we notice that we have something in the same. Both of these are being multiplied by x plus 1. So since it's being multiplied, I can factor that out. They have that common factor. So I pull out the x plus 1 and look what I have left. Do you notice what I have left? X plus 3. And so if I pull out that x plus 1, I'm left with x plus 3. And we know that if we multiply this, we get x squared plus 3x plus x plus 3, or x squared plus 4x plus 3. We are able to turn this into a product of two binomials. This is called A times C. Now, we get here, again, we look, we go through the criteria. Is it in standard form? Yes. Is there a common factor? No. Is it a special case? It's not the difference of squares because it's 3 terms. Difference of squares is always 2 terms. It's not a binomial square because my third term is not a perfect square. So we go to A times C. My A value is 1. My C value is 7. Remember, this is ax squared plus bx plus c. My A is 1. My C value is 7. Now I find factors of 7. There's only one set of factors of 7, which are 1 and 7. My sign, since this is positive, that means the signs are the same. They're either both positive or both negative. And so I looked here, and it tells me that they're both positive. So I'm going to make these signs here both positive, and then I'm going to combine them. Positive 1, positive 7 is positive 8. That is equivalent to my middle. This is my middle. So I'm going to take these two values. We'll see when we get more factors where this comes into play. So I'm going to take this value 1 and 7, and I'm going to rewrite this trinomial. I'm going to bring down my x squared. Instead of writing 8x, I'm going to write plus x plus 7x, because x plus 7x equals 8x. And then I'm going to bring down my third term. Now I'm going to factor by grouping. I'm going to group the first two and the second two. I'm going to look for a common factor in the first two. That is x. That gives me x plus 1. I'm going to see the second two, 7x and 7. I can factor out a 7. That leaves me with x plus 1. These must be the same. They must be the same. If they are the same, then I know I did it right. I'm going to pull out that x plus 1, and that leaves me with x plus 7. And that is how you factor a trinomial. Super easy, super nice. 14, good. Okay, so let's go through. Standard form, yes. Common factor, no. Special case, not the difference of square, not a binomial square either. I'm going to do a times c. My a value is 1. My c value is 14. So now I have factors of 14. 1 and 14, 2 and 7. That's it. My signs are the same. And now I look here and, oh, this time they're both negative. So negative, 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 negative. And now I'm going to combine them. Negative 15, negative 9. So now I'm looking for the pair that is equal to my middle negative 9. So this is my middle value. So I'm going to use these two values. I don't use negative 1 and negative 14 because that would give me negative 15. And my outside and inside does not equal negative 15. My outside plus my inside equals negative 9. So I'm going to use those two values. C squared minus 2c minus 7c plus 14. Remember, this has to equal negative 9c, which it does. So now I'm going to take that and I'm going to factor by grouping. I'm going to group the first two and the second two. C squared minus 2c, I can factor out a c, and that leaves me with c minus 2. My first term is negative, so I have to factor out a negative 7. That leaves me with c minus 2. Remember, if we want to check, negative 7c, positive 14. So make sure that you still get it. And I also see that my parentheses are the same. They must be the same. Now I'm going to factor that out. I'm going to pull that out because they both have that in common. If I remove it, it leaves me with c minus 7. Where did I get the c minus 7? Right here. Okay, that's where the c minus 7 is coming, and I'm done. And if I multiply that back real quick, I get c squared minus 7c minus 2c plus 14, or c squared minus 9c plus 14, which is my starting trinomial. Number 1, standard form, yes. Common factor, no. There's no common factor. There's no common coefficient. There's no common variable amongst the three. So that's what common factor means. 3 is special case. No, it's not difference of squares. No, it's not a binomial square. 12 is not a perfect square. So we're going to do a times c. So a is 1, c is 12. Factors of 12. We have a couple more factors this time. 1 and 12, 2 and 6, 3 and 4. my signs are positive means that the signs are the same and they're both negative, because a negative times a negative equals a positive. So negative, negative produces positive 12. Negative 2 times negative 6 produces positive 12. Negative 3 times negative 4 produces positive 12. Remember, this is always going to be a product of two numbers. And then we're going to add. This is representing my outside and inside. That makes negative 13. This makes negative 8. This is negative 7. So remember, this is the sum of two things. So which one equals negative 8? This pair. So my outside and inside is going to be negative 2 and negative 6. So we rewrite this trinomial into a polynomial, y squared minus 2y minus 6y plus 12. Let's remember where these values come from. The y squared is this. The negative 2y and negative 6y comes from this. And then the positive 12 comes from there. Okay, that's where all these values are coming from. I'm not making them up. There's a form, there's a format, there's a technique. Let's look at the first two. Now we're going to factor by grouping. Y squared minus 2y, we can take out a common y. That leaves us with y minus 2. You have negative 6y plus 12. Since my first term is negative, I have to factor out a negative. And I can factor out a negative 6, which gives me y minus 2. I know that I did it correctly because both of my parentheses are the same. So let's take out that y minus 2 and we get y minus 6. And notice my signs are the same, negative 2 and negative 6, which makes positive 12, with an inside and outside of negative 2 and negative 6, which makes negative 8y, and it all makes sense. Really, really nice, very, very systematic. The way that I was taught in high school was way crazier, way more convoluted. This is pretty straightforward. You can use this technique for when the signs are different, when our A is more than 1. And so I like that aspect to this because we can just consistently do the same exact steps, procedures, no matter how complex the problems become. So standard form, yes. Common factor, no. Special case, it's not the difference of square, it's not a binomial square. 6 is not a perfect square. 4 is going to be A times C. A is 1, C is 6, factors of 6, 1 and 6, 2 and 3. Signs are the same when that is positive, and we know that both are negative. So we make those factor pairs negative, negative. That makes negative 7. That makes negative 5. Which one is equal to my middle? That's going to be negative 5. So I'm going to pull those two factor pairs. And we get r squared minus 2r minus 3r plus 6. Factor by grouping. We're going to factor out an r. You get r minus 2. We're going to factor out a negative 3 because my first term is negative. And you get r minus 2. R minus 2, R minus 3. And remember, we could always check. The way you check is you just multiply those two binomials. We should be able to multiply those two binomials super quick, and we can do it mentally because we've done them so much. Standard form, common factor, special case, A times C. So A is 1, C is 12. Factors of 12 are 1 and 12, 2 and 6, 3 and 4. Signs are the same, both are negative. And now we're cooking real quick. We can get through this super fast, 13. So we get p squared minus p minus 12p plus 12. We're going to factor out a p from the first, that's p minus 1. We're going to factor out a negative 12, that's p minus 1. And we get p minus 1, p minus 12. Yeah, again, look where we are. We're doing problems in less than 60 seconds. That is what we shoot for. Can we be so efficient with these problems that we can save ourselves time, being efficient, being fluent, being, we're attacking, we're driving the bus. We're not in the back being dragged along. We are driving the bus. We are setting the tempo. Standard form, yes. Common factor, no. Special case, no. A times C, 1 times 14 is 14. 1 and 14, 2 and 7, and that's it. Signs are the same. Both are positive this time. 15, 9. 15's my middle, so I get q squared plus q plus 14q plus 14. We're going to factor out a q. We get q plus 1. We're going to factor out a 14. We get q plus 1. So our answer is going to be q plus 1, q plus 14. And I'm going to reiterate, if you want to check, multiply those two out, do the FOIL first, outer, inner, last, and make sure that you get your starting trinomial. There's no reason for you to get it wrong because you can check your solution. You can multiply out those two binomials to make sure that it creates your starting problem. Standard form, yes. Common factor, no. Special case, no. A times C, 1 times 14 again. 1 and 14, 2 and 7, signs are the same. Both are positive. 9 is my middle. N squared plus 2n plus 7n plus 14. We're going to factor out an n. You get n plus 2. We're going to factor out a 7. N plus 2. I did it right because I have two binomials with n plus 2. If we pull that out, we get n plus 7. Standard form, common factor, special case, A times C, 1 times 22 is 22, 1 and 22, 2 and 11. You're going to see the benefits of doing all of these problems because we have a boatload. This is going to be a long video. We have a boatload of things, but as it becomes more complex, we're going to see where the efficiency and the technique and doing all these helps us. So signs are the same. Both are negative. So negative, 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 negative 23, negative 13. My middle is negative 13, so I'm going to use these two as my outside and inside. Negative 2a, negative 11a plus 22. Factor an a out, you get a minus 2. Factor negative 11, you get a minus 2. A minus 2, a minus 11. Standard form, common factor, no. Special case, no. A times C, 1 and 30 is 30. Ooh, there's some good factor pairs. 1 and 30, 2 and 15, 3 and 10, 4 no, 5 and 6. Signs are the same. Both negative. Negative, 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 negative. Negative 31, negative 17, negative 13, negative 11. Ah, notice none of them are my middle. I love that they did this. Thank you. None are equal to my middle. So we say if the polynomial is not factorable, we write prime. Now, this is a little bit misleading. This is just, we're up to technique 4. There's technique 5 and there's technique 6 also. We can use the quadratic formula, which we will learn a little bit later. But if we don't have factors, that means it's not going to have a whole number intercept or 0. It just doesn't have, it doesn't break into whole numbers for our constant. It'll still be S. It'll still be negative because the signs are the same, both are negative. It's just these numbers are not whole numbers. They're going to be decimals. They're going to be different answers. Okay, so it may be fractional. It also may be no solution. It may be above the x-axis and may not intersect. Let's show you this. Let's do this just for the time being. Let's do Desmos, and let's graph that. Y equals x squared, what is it, minus 12? Minus 12x plus 30. Yeah, so it does, you have two intercepts. Notice that the intercepts are decimal values. If we did the other one, let's do one that has a whole number. So if we do negative 13 and 22, notice that those are whole numbers where they cross the x-axis, 2 and 11, and notice negative 2 and negative 11, because we would solve what value for A makes this 0. So we talked about that in a little bit later section, but that's what's going on. That's why we say prime. It's just a it's just going to have a value that is not a whole number. That's what that means. But at this point in this section, you would write prime. We'll learn how to get those decimal answers a little bit later on in maybe chapter 5, maybe chapter 12. All right, so let's keep going. Not blue, let's do black. It's in standard form. There is no common factor. It is not a special case. A times C, 1 and 32. We have 1 and 32, 2 and 16, 3 no, 4 and 8, 5 no, 6 no, 7 no, and we're back to 8. Signs are the same, both are positive. How can I say that? I'm not looking to see if these two signs are the same. That's not what's same and they're both positive. That's not what it means. Remember, this is a product of two numbers. We have my last times my last. And the only way you can get a positive through a product of two things is if they're both positive or if they're both negative. So that's what I mean, that the signs must be the same. Not these two signs are the same. And since they're the same, they're either both positive or both negative, I can find out what they are by looking at that. Because remember, then we're going to combine, then we're going to add those two to produce my middle term. So since this is positive, I know that both of those signs must be positive. Okay, so understand that when I ask, are the signs the same or different, I'm looking just at that sign. So they're the same, and then I look here to find out what they are. A lot of students make that mistake there. 18 and 12. My middle is 18, so I'm going to take that as my outside and inside. X squared plus 2x plus 16x plus 32. We're going to factor out an x. We get x plus 2. We're going to factor out a 16. We get x plus 2, x plus 2, x plus 16. Yes, some of you are going to notice, hey, those are the two numbers that I get, positive 2 and positive 16. Not that one. Negative 2 and negative 11. Positive 2 and positive 7. Yeah, that's going to happen when your A value is 1. You will notice that that will produce the two factors in the binomial. That is true. When we get down the road in 5, 8 or maybe 5, 9, when our A value is 1, that's not going to be the case. We're going to have to do a little bit more. When we factor by grouping, we're going to get a coefficient for our first. So we'll just keep doing it, stick with it. I like if you notice some certain things. 4 is a times c, 1 and 26. 1 and 26, 2 and 13, that's it. Signs are the same, both are negative. Negative 27, negative 15, those are my middles. X squared minus 2x minus 13x plus 26. Factor out an x, you get x minus 2. Factor out a negative 13, and you get x minus 2. X minus 2, x minus 13. Good. Going through it. Oh, here we go. Think negative factor 16 in your head. Okay, I don't know what that means. We're going to keep doing this. Number 1, is it in standard form? Yes. Is there a common factor? No. Is it a special case? No, 30 is not a perfect square. I can't wait. Hopefully they'll give us one that it might be a special case. A times c is 1 times 30, which is 30. 1 and 30, 2 and 15, 3 and 10, 4, no, 5, yes, 5 and 6, signs are the same, both are positive. 31, 17, 13, 11. 10 is my middle, so this is prime. None of those add up to 10, factors of 30. Yep. Here we go. Standard form, common factor, special case, no. A times c, 1 and 60, 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, and that's it. Signs are the same, both are negative. Negative 16, negative 17, negative 19, negative 23, negative 32, and negative 61. My middle is negative 19, so we're going to use that. Negative 4 and negative 15. Negative 4x and negative 15x equals negative 19x. And we'll bring down our 60. So we're going to factor out an x. We get x minus 4. We're going to factor out a negative 15. We get x minus 4. X minus 4, x minus 15 are my two binomials that produce that trinomial. Standard form, common factor, special case, a times c. 1 and 54. 1 and 54, 2 and 27. 3, 3 and 18. 4, no. 5, no. 6, yes, 6 and 9. And that's it. Signs are the same. Both are negative. Negative 15, negative 21, negative 29, negative 55. 21 is my middle. So we have k squared minus 3k minus 18k plus 54. We're going to factor out a k. We get k minus 3. We're going to factor out a negative 18. We get k minus 3. K minus 3, k minus 18. Here's that repetition, just doing it over and over, again and again. Makes it rote, and we know that when we do it, we're just going to run right through it. It's going to be super easy. We can keep that efficiency, we can keep that speed, and we can be able to do this relatively quickly. 5 and 18, 6, yes. 6 and 15, 7, no. 8, no. 9, yes. 9 and 10, signs are the same, both positive. So my middle is 23. Which one equals 23? This one equals 23. So I can do it in that fashion opposed to adding all those up. Look, we're looking for 23. Let's just shoot for it. Let's look for that pairing. So that's 5n plus 18n plus 90. Factor out an n, you get n plus 5. Factor out an 18, you get n plus 5. N plus 5, n plus 18. During the assessment, you should be checking every answer. Checking would take one second. No, checking takes like 5 seconds. So standard form, yes. Common factor, no. Special case, no. A times C. 1, 21. 1 and 21, 3 and 7. Signs are the same, both are negative. Negative 10 is here. K squared minus 3k minus 7k plus 21. Factor out a k, factor out a negative 7. And this is how fast we can get this done. Standard form, common factor, special case, A times C, 1 times 45, 1 and 45, 2 no, 3 and 15, 4 no, 5 and 9. Signs are the same, both negative, negative 14. So we get x squared minus 5x minus 9x plus 45. Factor out an x, x minus 5. Factor out a negative 9, x minus 5, x minus 5, x minus 9. That's a bad 9. All right. Standard form, common factor, special case, A times C. 1 and 12, 1 and 12, 2 and 6, 3 and 4, signs are the same, both are positive. And I need it to equal 7. That's 3 and 4, plus 3k plus 4k plus 12. Factor out a k, factor out a 4. We get k plus 3, k plus 4. 48, standard form, common factor, special case, A times C. 1 and 48. That's going to be 1 and 48, 2 and 24, 3 and 16, 4 and 12, 5 no, 6 yes, 6 and 8, and that's it. Signs are the same, both are negative, which makes 16, that's here, negative 16. So x squared minus 4x minus 12x plus 48. Factor out an x, factor out a 12, x minus 4, x minus 12. Let's see how they're going to, hopefully they mix it up a little bit. Let's see what complex, but keep going. Put an hour in. It's just like basketball, shooting free throws. Standard form, common factor, special case, A times C, 1 and 20, 1 and 20, 2 and 10, 4 and 5. You see how you start getting better with your factor pairs too, and your times tables. This really does help you with that. Negative 11, prime, at least they gave us a prime one. 72, standard form, common factor, special case, A times C, 1 and 72. 1 times 72 equals 72. Factors of 72 are 1 and 72. 2 and 36. 3 and 24. I think 24. 4 and 18. 5 no. 6 yes. 6 and 12. 8 yes. 8 and 9. And that's it. Signs are the same, both are positive, and they need to equal 22. That's right here. So 4 and 18 plus 4x plus 18x plus 72. Factor out an x. Factor out an 18. X plus 4. X plus 18. Ah, yes, standard form. No, it's not in standard form. So we got to write them in standard form. Z squared minus 17z plus 72. Now we go, is there a common factor? No. Is it a special case? No. A times C, 1 and 72. Factors are 1 and 72, 2 and 36. 3 and what did we say? 24, 4 and 18, 5 no, 6 yes, 6 and 12, 7 no, 8 yes, 8 and 9. Signs are the same. Both are negative to make 17. Negative 17. So z squared minus 8z minus 9z plus 72. Factor out a z. Z minus 8. Factor out a negative 9. Z minus 8. We get z minus 8, z minus 9. Those don't have to be in any order. You could do z minus 9, z minus 8. Again, standard form. Nope. Let's move it in standard form. C squared minus 12c plus 20. Okay. Now is there a common factor? No common factor. Is it a special case? No. Is it A times C? Yes, we'll do A times C is 20. 1 and 20, 2 and 10, 4 and 5. Signs are the same, both are negative, which equals negative 12. That's this pairing. So we get c squared minus 2c minus 10c plus 20. Factor out a c, c minus 2. Factor out a 10, c minus 2. You get c minus 2, c minus 10. All right, let's see if they can change it up again for me. Come on. Give me. Let's just take a peek and see. Ah, okay. We get a, oh, there's still a lot of problems to do. Hiya. Okay. Standard form. No, it's not in standard form. Let's put it in standard form. A squared minus 15a plus 54. Common factor. No, there is not a common factor. Is it a special case? No, it's not a special case. A times C. A times C is 1 times 54, which is 54. 1 and 54, 2 and 27, 3, yes, 3 and 18, 4, yes, no, 4, 5, no, 6, yes, 6 and 9, and that's it. Signs are the same, both are negative. Negative 15 is this factor pair. A squared minus 6a minus 9a plus 54. Factor out an a minus 6, factor out a negative 9, a minus 6. We get a minus 6, a minus 9. Standard form? Nope. Let's put it in standard form. Well, 63. Common factor, no. Special case, no. A times C. 1, 63, 63. 1 and 63, 2 no, 3 and 21, 4 no, 5 no, 6 no, 7 yes, 7 and 9. Signs are the same, both are negative. Negative 16. So we get c squared minus 7c minus 9c plus 63. Factor out a c, you get c minus 7. Factor out a 9, you get c minus 7. C minus 7, c minus 9. I may be only doing one video today. This is exhausting. This is, oh, here we go. It's still exhausting. All right, what's the difference? The difference is we have a squared variable in the front and the back. So look, we know that it's going to be xy, xy. Well, we know our first term is just going to be x, because that's the only way you can get this. But we'll have a coefficient. I know my signs are going to be the same, and they're both going to be negative. So now I just got to find this number. So I'm not changing anything. I just need to make sure that I have this variable y in my lasts, because that is how I get it. And think about it, my outside and inside, let's do it in this color, my outside and inside would produce an xy, hence why we have a middle term of xy. So just something to keep in mind and think about the logical part. We still go through the same processes. Is it in standard form? Yes. Is there a common factor? No. Is it a special case? No. So we have to do a times c. A is 1, c is 28. Factors of 28, 1 and 28, 2 and 14, 3 no, 4 and 7. And that's it. Signs are the same. Both are negative. Negative 29, negative 16, negative 11. This is equal to my middle. So this is what we get. We still bring down the first term. And now our middle term is going to be negative 4xy and negative 7xy. That simplifies to make negative 11xy. And then we pull down our third term. No different than what we've been doing for the first 26 problems. We still are going to factor by grouping. And it'll be interesting to see, what do they have a common factor? They have a common factor of x. If we factor out an x from the first two, you get x minus 4y. If we look at the second two, we're going to factor out a negative 7y. Ooh, because they not only have a coefficient in common, but they have a variable in common. We take out that negative 7y, we get x minus 4y. Are they still the same? Did I do it correctly? Yes, they're still the same. They have to be the same. If they're not the same, then you know you made a mistake. Let's pull out the x minus 4y. And what are we left with? X minus 7y. X minus 7y. So there is my answer. And hey, let's look at what we had proposed. We knew it was going to be x minus something y times x minus something else y. And that's what we got, yeah. And does our outside and inside, negative 7xy, negative 4xy, which makes negative 11xy. So it worked. We can still check. Is it in standard form? Yes. Is there a common factor? No. Is it a special case? No. We'll do a times c. My a value is still 1. My c value is still 18. It's the coefficient of that term. And that's 18. 1 and 18, 2 and 9, 3 and 6. Signs are the same, both are negative. And this equals my negative 9. I get a squared minus 3ab minus 6ab plus 18b squared. We can factor out an a, that gives us a minus 3b. We can factor out a negative 6b, that gives me a minus 3b. A minus 3b times the quantity a minus 6b. So even though the starting problem was far more complex and complicated, notice I was still able to do it relatively efficiently and fast. I'm still doing it within 30 seconds. Standard form, yes. Common factor, no. Special case, no. A times C, 1 in 45. 1 and 45, 2 no, 3 and 15, 4 no, 5 and 9. 5 and 9? 5 and 9. Signs are the same, both are negative. Negative 18 is these two pairs. C squared minus 3CD minus 15CD plus 45D squared. Factor out a C, C minus 3D. Factor out a negative 15D, C minus 3D. C minus 3D times the quantity C minus 15D. Now, looking at that starting problem, I doubt you can look at it and understand and find the two numbers or the two binomials that would produce that. To me, that's impressive. That's crazy, crazy good. So that's the cool thing about this. Look at the efficiency, look at the speed that we can do this. It's quite amazing on how fast and efficient this process works. 21, 1 and 21, 3 and 7, signs are the same, both negative. Negative 10, this is how fast we can do it. 3xy minus 7xy plus 21y squared. Factor out an x, x minus 3y, factor out a negative 7, whoop, 7y. Don't go so fast, you start making silly mistakes. You get x minus 3y, x minus 3y, x minus 7y. And when this sign changes to a negative, we're going to have some interesting things that we have to look at. It's not that we're going to change the process. Much like we don't change the process when A is 1, it's just things change. Just some certain things change and we just have to be aware of it. So not a hard thing. We'll get to it in due time. Standard form, yes. Common factor, no. Special case, no. A times C, yes. 1 and 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Signs are the same, both negative. Wow, they love same negatives. 14. Negative 14. C squared minus 2CD minus 12CD plus 24. D squared, factor out a C. C minus 2D, factor out a negative 12D. C minus 2D. And we can start seeing how fast we can complete these problems. You get this done, you're going to be really good on your placement test. I promise you. Standard form, common factor, and we'll see, I think it's section 510, where they give you all the different types, and going through this process is going to be really, really beneficial. Special case, no. A times C. We're going to do problems where there is a common factor. Okay, so it's there, it's coming. Just be patient, keep doing these, doing all these so much. Oh my gosh, we're going to have to put an hour in. Well, maybe it's an hour and a half. Maybe it might even be 2 hours of math work. But putting it in is going to pay huge dividends. And that's the thing. You have to make these little teeny sacrifices. it's just part of the process. 5 and 6. I know you want to go out and play. I know you want to be on your computer or your phone. And it's just, you know what? If you invest the time right now, you get paid out really, really big dividends. That makes a huge difference in your experience, in your math experience. So be patient, put in the time, and you will get the rewards of your efforts. And in this day and age, when people are looking to do shortcuts, looking to do less work, the person who's doing above and beyond work is going to stand out, and it'll make you a leader amongst your peers. And hopefully that is your goal, to be a productive human, somebody who gives back to your community, to your society. You make a positive impact on the world. Don't just consume. What can you give back? Standard form, common factor, special case, A times C. 1 in 48. 1 in 48, 2 in 24, 3 in 16, 4 in 12, 5, no, 6 and 8. Signs are the same, both are negative. 16 is going to be this pair. Y squared minus 4yz, minus 12yz plus 48z squared. We're going to factor out a y. You get y minus 4z. Factor out a negative 12z. You get y minus 4z. Y minus 4z. Y minus 12z. Standard form, common factor, special case, A times C, 1 in 45. 1 in 45, 2 no, 3 and 15, 4 no, 5 and 9. Signs are the same, both are negative. Negative 18. A squared minus 3ab minus 15ab plus 45b squared. A minus 3b, negative 15b, A minus 3b. A minus 3b, A minus 15b. We're good. 45. All right, we're kind of, yeah. Whew. 2 more. Here we go, baby. One of the longer videos. Standard form, yes. Common factor, no. That's not a 3. Special case, no. A times C, 1 in 24. 1 in 24, 2 in 12, 3 in 8, 4 in 6. Signs are the same, both are positive. It equals 10 right here. D squared plus 4DE plus 6DE plus 24E squared. Factor out a D, we get D plus 4E. Factor out a 6E, we get D plus 4E. D plus 4E times the quantity D plus 6E. So weird seeing those variables in there. Last one, here we go. Standard form, yes. Common factor, no. Special case, no. 72 is not a perfect square. Why do I always do 72? Well, this is a perfect square, but your first and your third in your binomial square has to be. So that's why I'm always saying that. A is 1, C is 72, 1 in 72, 2 in 36, 3 and 24, 4 and 18, 5 no, 6 yes, 6 and 12, 7 no, 8 yes, 8 and 9, Signs are the same, both negative 27. That makes negative 27. Y squared minus 3yz minus 24yz plus 72z squared. Factor out a y, you get y minus 3z. Factor out a negative 24z, and you get y minus 3z. Y minus 3z, because they have that in common. If you pull that out, you're left with y minus 24z. And that, my friends, is section 5-7. Ooh, that was a long one, but well worth it. Hopefully you invested that amount of time, and I want to, again, reassure you that being familiar, so familiar that you know how to go. Good luck.